Number 13, from the top of a 550-foot cliff, a hiker looks down at a river below. Her angles of depression to the near and far riverbanks are 70 degrees and 50, as shown in the picture. Based on this information, how wide is the river? Well, let's fill this in. So we know with alternate interior angles that since these two lines are parallel and there's two transversals, that the line here touching 70 is also 70 degrees there, and this line touching 50 is also 50 degrees there. We want to know the width of the river. So if I want to use law of sines or cosines, I have to know some lengths in this triangle, which I don't. But I can see that I have a triangle here, that's a right triangle, and I have another right triangle this way. Here's how my plan is to solve this. What I'm going to do is I'm going to find the width of this big, large triangle here. Let me just draw it for you. I'll try to find the width of this triangle first, the x value of this triangle, and then we'll come back and solve this one. So first, we'll call this x1. If I wanted to find x1 here, I'm given a y. Now normally we want our unknown on top, so I want x1 over my y, which is 550. Now what relationship is x over y? That's cotangent, because it's the reciprocal of tangent. It could be cotangent. Now we want to use the angle that's on the x-axis. So for this long triangle, the angle on the x-axis is here. This is not a part of the angle, because this is on the big triangle, this is the angle. So I'm going to say cotangent of 50. And to solve this, all I'll do is multiply both sides by 550. And so we come over here to our calculator. And so I'll go calculator, 550, because I usually write that in front of the trig function. Cotangent of 50 degrees equals 461.5 feet. So that right there is 461.5 feet. That's our x1. Now we're going to do this again, but this time our triangle is going to be different. We're now going to look at this triangle, and we're going to call this x2. Let me try to line that up again. So this time I'm going to solve for this x, and I'm going to call it x2. So I'm now finding this one. And so I would have x2 over 550 equals, since it's x over y, it'll be cotangent again. This time my angle is changed to 70 degrees. And again, my step is the same. I'll multiply by 550. And we'll see what we get here. So I'm basically typing in the same thing. The only difference is my angle has changed to 70 degrees. And I get 200.2 feet. So we'll get my color coordinating here. 200.2 feet. Now this was x1. This was x2. So to find the actual width of the river, I'm going to call that x here. How will I get x? Is I'm going to take my x1, which was, remember, from here to there, that was x1. And this right here is x2. I'm going to take my x1 and subtract x2. So this would be x1 minus x2. That's the plan here. And so here's what I'll do. I'm just going to draw a line. I'm going to subtract these. So I'm subtracting x1 minus x2. So when I subtract these from each other, I would get 261.3 feet. That is the width of the river. And we could go back up here and just check with the calculator if you wanted. So that answer minus this answer gives us 261.3.